Hi, welcome back. This is the beginning of Unit 8, Week 9, Lecture 19. And in this particular lecture, we're going to talk about how plastics and drugs are related and whether or not they are actually indeed related or not. Okay. As it turns out, one way in which they are related is that both plastics and drugs are considered organic compounds. Okay, and when we say organic compounds, we mean carbon-based compounds. The other way that plastics and drugs are related is that both plastics and drugs can be engineered. Okay, and what we mean by that is that the polymer chemist or the pharmaceutical chemist will decide on what characteristics they want their compounds to have, and then they'll seek to synthesize compounds that would display the types of macroscopic properties that they would like. Okay, and we saw that in the previous weeks when we were talking about polymers, how just by changing, for example, one of the hydrogens on ethylene for styrene or a methyl group, and you can get different properties for your plastics. And so we're going to see a little bit about how we do that with drugs today. So I want you to think back and remember the condensation reaction. We looked at this reaction early on when we first started talking about organic reactions. And we said that, you know, salicylic acid will react with acetic acid. So the hydrogen from the alcohol group on salicylic acid will react with the hydroxide portion or the OH portion of the acetic acid to split off and form water, and the product is acetyl salicylic acid, which is an ester. Well, as it turns out, the common name for this particular compound is aspirin. Okay, so this is an example of engineering a drug to give the desired physiological effect. So what happened was, a long time ago, people had found that the tea of willow bark was a good pain reliever and fever reducer. And willow bark is from the willow tree. And what they would do, this is going back several thousand years, is take that willow bark and boil it in water. And when they did that, certain compounds were extracted from the bark. And so it was an herbal remedy that was given to people. Well, in about the 1700s, as chemistry was evolving as a science, people started looking and trying to decide what was it in this tree bark tea that was the effective agent. And so they crystallized out the solids and found that different crystals came from the tea when you removed the water, and they got it down to a couple groups of crystals, and they found that the crystal that was salicylic acid was the active ingredient. But the problem was that salicylic acid tasted really horrible, and it caused stomach upset. So a chemist realized to make it less acidic, if they could react away this hydroxyl group, it would make the carboxylic acid part less acidic. And so by just reacting with acetic acid, then they could create an ester here. And it made the drug more tolerable for people. So that's an example of engineering a drug for a specific purpose.